Software Engineering Radio episode 67, Roundtable on Model-Driven Development and Product Lines. Welcome everybody to Software Engineering Radio. This is the first time we're actually recording a roundtable discussion. We're here at Ulrich Eisenegger's conference in Leipzig. It's called, what is it called? Product Line and Product Line Engineering or something. Okay, so it's about I can read this. Model-Driven Development and Product Lines, Synergies and Experience. Okay, so, and the nice thing about this conference is that a number of experts on those topics are actually here, and so I thought we have to get them together and talk a little bit about some of the topics. But before we actually go ahead and start the roundtable discussion, I want to remind you again of our pending survey. Again, we did get responses, but we will keep this open until we have at least 500 responses. We do want to get a significant number of responses, so we have a statistical basis for the results so that they are significant statistically. And therefore, please go ahead. If you didn't answer the survey yet, go to our website, se-radio.net, click on the survey link and take the survey. It's only 5 minutes and you can win a book. Willie has given us an instance of the POSA 4 book, we have a POSA 5 book, we have SOA books, we have my book on model-driven development, which fits the topic today, and more. So please go ahead, take the survey. You're doing us a great favor. Okay, but now let's go ahead and introduce the people in our roundtable discussion. You probably know my voice since I've been on the podcast a number of times, so I'm not going to introduce myself. So let's just start with introduction.
My name is Juha Pekka Tolvanen. I come from company MetaCase, and my interest area on this topic is basically meta-modeling and building domain-specific languages to automate software development.
My name is Tomas Tai. I'm working at B&M Informatik, and I'm interested in everything that has to do with process and methods. And there's one tool thing I'm associated with. It's open architecture where something like the grandfather.
People have heard about OAW a couple of times. We've had 2 or 3 episodes talking about it. So
2 or 3, yeah. Yes.
Not too many, but
okay.
My name is Danilo Beuche. I'm with a company called Pure Systems, and my main interest is in software product lines and how to get it done in reality.
My name is Axel Uhl. I'm with SAP in a group called Product Architecture, and in that group my responsibility is taking care of SAP's design time tools and repositories.
I'm Ruediger Schilling with Delta Software Technology. The company calls itself the Generator Company. Hence, my interest is in any kind of generative programming in automatic of software development processes.
Okay, so let's get started on some of the questions. So let's start with taking a look at the official world of model-driven development, which is more or less the stuff that the OMG publishes. OMG's MDA standard, QVT, MOF, these kinds of things. So anybody has any opinions about how relevant some of these standards are? Probably some of them are more relevant, like MOF, and some of them are maybe not so relevant. Anybody who wants to say something about that?
Maybe I can start with the first comment. You thought so that I would comment on that one, right?
Yeah.
I have followed the evolution of MOF starting with version 1.4, and now we're in version 2.0, if I'm not mistaken. And I've seen a lot of technical work going on at the OMG, and not all of that, I have to say, was actually helping promote the standard. I think the OMG was kind of trapped by IBM, IBM forcing that split into EMOF and CMOF upon the OMG, and the OMG just seemed to blindly follow that. Then eventually IBM not truly adopting even EMOF. When you look at the current EMF implementation, it is not exactly compliant with what the OMG has with EMOF. And now eventually the MOF standard has become kind of, well, it's a big split, and it is very complicated to implement nowadays, doing a full MOF 2.0 CMOF implementation. Now, eMOF, for example...
You're working on this, right?
Yes,
so you do this.
We do MOF 1.4. We did take a close look at MOF 2.0 because we thought some of the things in MOF 2.0 might be of interest to us. Then again, some of the things that we thought should have been in, especially when you look at UML2 with its superstructure, it would have been so nice if they finally got it to put the key qualifiers into the associations, also useful for MOF. They did not do it. And so we are stuck kind of with MOF 1.4, which was the last implementable but still scalable version. And I think the OMG has not done itself a good service in allowing for that split.
Interesting to hear that the people who make the standards, they don't follow it, but that's nothing new. Basically, it's good to have a standard, but only at the point of time when we know what's working. And as of today, there's clearly not a modeling language yet, for instance, like UML, which we would not be working for model-based development. It's more like model-based sketching. The same idea is with the XMI. The XMI has many versions, and XMI doesn't really work between the tools. Earlier, when we had other standards, like in 80s, we had PCTE, it didn't work. At 90s, we had CDIF, Case Data Interchange Format, it didn't work. So it doesn't surprise that XMI is not working either. It's good to have standards, but let's first make something which works, and then let's standardize. And unfortunately, that's not the way how OMG works.
Regarding XMI, I agree it's a mess that the OMG has created. I think it's partly due to the fact that the OMG processes are lousy. They don't require you to do a reference implementation, and they don't require compatibility and compliance testing. Now that has been solved in a better way with the JCP, where the people are required to publish test kits and stuff like that.
So do we have any opinion on QVT, the Query View Transformation Standard? Is there anything happening?
Well, I think that's a good example for standard, or try to come out with a standard which has no practical background, because it is a complete new field, and there are so many topics in that area. And I think when this project started, nobody was able to really get the point what is good and what is bad and what is appropriate. And I think the QVT standard, which we can read now, exactly reflects this this state.
There was no experience in model-to-model transformations when they did the standard, right? So
they've defined 3 languages, and they're...
It's a good example of carrying out research in a standardizations organization, and what you get is the mess that we currently get.
It sounds like we're all relatively skeptical about these things. Is anybody there who wants to raise the flag for the OMG in there? No?
Just to be fair, the standards did have a good effect on the development of the whole field. I think without MOF and its standardization, we wouldn't be where we are. And also, I think UML has helped a long way. So I would partly disagree that you cannot do anything reasonable with UML. At the company that I used to work for before, at Interactive, we did a whole lot of very useful things with UML. And again, that is, partly due to the OMG. Well, of course, we know the 3 amigos contributed that stuff to the OMG. And then, the critics would say then the OMG kind of destroyed it afterwards. But
So today, during the conference, I noticed something which wasn't really new to me, but it became obvious. I think although this is a very relatively small community we're in here, all this modeling and generative and product line stuff, I think the community isn't able to agree on a common terminology. For example, there are those different terms: model-driven engineering, model-driven architecture, model-driven software development, generative programming. Then people talk about models, DSLs, or metadata. About meta models, domain models, or schemas. Then there is all this technology stuff, Microsoft tooling, versus Eclipse versus some of the more proprietary solutions which sit next to me. So do you think that it's a problem for the development of this whole approach that the community, although it's small and it's probably in its infancy, is already splitting and can't even agree on common terminology?
I think some of the terms that you mentioned do have a pretty well-defined meaning. It is just that some people tend to confuse them constantly.
Right.
The question is what the root cause of the problem is. Is it the unknowingness of the people who just don't care about the terminology and just use the terms any way they like? So, for example, when you mention DSL and metamodel, of course, there's a clear distinction between the two concepts. Like a metamodel just defines the abstract parts of a syntax, whereas a DSL is much more than that. So maybe it is more about the ways that the terms are being used by, well, let's say some of the not so literate people.
So my impression, to some degree, is not only that people are misunderstanding it, that everybody is misunderstanding it in a different way. And so that makes things a little bit more difficult. Even this morning we heard when we're talking about product families and product lines and system families. Sometimes there are unnecessary distinctions, just to say, well, this is a very specific thing. It needs a very specific name. And sometimes the wordings are overlapping. And this makes it more difficult to deal with. And the problem is the reason for it is probably that it is yet not mainstream by any meaning. And that means there are a lot of people working separately. Everybody has his own ideas, and sometimes we meet in conferences like this, but we didn't have a chance to build a community. And a community where we can talk about these things and we can build up a common wording.
Although cynically one could say that it would be a useful thing for the OMG as a standards body to make sure that these terms are really properly defined. But it seems like they're doing other stuff. Danilo?
I think it's partly because we are relatively alone and go out into the world, discuss it with our customers in some sense, and discuss it in their terms, and then we do things which are not okay and don't use the exact term just to be able to talk to the customers, and then we meet and then we have the problem that we use the wrong terms, even if we know, if we would think about it, that we don't do the right thing.
In the model-driven world, I think we agree that round-trip engineering is typically not very useful because the models are more abstract than the code that's generated, so there is no easy mapping back from the code to the models, right? Right, okay. However, there is another initiative at the OMG, which, and I think this is really funny, actually uses an acronym that has the MDA letters reversed, which is ADM, which is the architecture-driven modernization thing, which is basically, that's what I understand, a kind of model-driven reverse engineering. So can somebody explain what this is all about and how it relates to MDA, or is that, I've always wondered about the back arrow from code in to the model in the MDA standard. Is it what's going on there, or what about this ADM stuff?
Yes, ADM is the wording is funny. It's just MDA reversely. But to understand it, it's not the exact idea that as we will take software, drop it into some kind of machine, and out comes some UML code. That's not exactly the idea. The idea is, though the wording gives the impression, the idea is to use some kinds of mechanisms to understand the applications. Just to understand existing, let's say, legacy applications, to understand what is in there in the application, what are the functionalities, what are the assets, and so on in several areas, in several directions. It is at least not up to date. There are nobody's trying to automatically derive models in like a UML model. There are standard models to express what is in the applications, but not just an automatic transformation. I cannot imagine it today, an automatic transformation from, let's say, an existing COBOL application, 120,000 lines of code, I've seen things like that, into just one UML model is without any use. But it is useful to understand the application. It's useful to express what you understood in agreed models. That's the idea.
So the idea is to standardize certain meta models that allow people to express software structures.
Yes, and again, the idea is that allows tool vendors to exchange what they find out. There are some who are specialists in, let's say, discover things, and the next one doing analysis tools and so on. I know this comes back to the question: how useful is XMI to exchange these informations? But we had the answer for that before.
Sounds like an OMG, because the issues of program understanding or architectural recovery, they are tough academical research questions today. They are not at all at the state of being standardized. But again, doesn't surprise me.
Well, I have another view on it, because there are already lots of tools out there in the market, and it's a necessary task. So we cannot wait until in the research all the questions are answered for that, because when they are answered, nobody's anymore interested in this answer. So it might be useful. It might be useful to, let's see, at least at the smallest common denominator, to find out what are the informations we can share and we can exchange with others. And in practice, we're doing it already. We're doing it with another company. They have analysis tools and transformations tools for other languages, and we have some analysis and discovery tools for existing applications. And it looks useful. As long, I'm afraid is the usual process is that more and more requirements are added, more and more functionality is added to the models until they are not useful anymore. That's a risk. But up to date, it looks like really something useful. It is completely based on MOF and only MOF, not UML. It's not producing UML.
So these meta models are comparable to what the CWM meta model does for data description.
Exactly. It's a similar approach, and it's overlapping. The data description part of CWM is used within ADM.
And we also agree as a community here that this is something different than what we talk about in model-driven development and MDA. It's not just simply the way back for round-trip engineering. It's really kind of a digging in the dirt, in the architectural, in the systems to find out what they're all about, right?
What is exactly the difference between MDA and ADM? If you have in both areas, you have meta models, domain-specific, describing architectural things or more business-related things, and there's not the intention to have round-trip engineering. So, what's exactly the difference? It's more intentional than formal, right?
One difference is where you start, right? You start with the model or you start with the code.
That's the difference. You start with the code, and you cannot expect the code to be, for instance, to be well designed and well architected. You don't have, for instance, you don't have things like classes in existing COBOL applications and so on. So you're dealing with different artifacts. You're dealing with different model elements. You can try to translate them afterwards, transform them into UML model elements, but it's to some degree, it's a different world, at least in the beginning.
Yes, but if you have, say, a DSL which describes those things, then you can perfectly use it to describe not only legacy applications, but to design new applications as well. Or don't you expect that?
I have no contradiction about that. That's a different approach. It's a different approach. Here is the approach to try to standardize the model to be able to exchange the data about the applications. That's it. A different approach starting with DSLs can help and will help, I know. And to some degree, we are doing it exactly that way. We're not using, we're not waiting until ADM is completely specified and defined. To say the truth, we're using the things that we think that are usable. Similar as we heard before with MOF. For instance, we're using still the old MOF 1.4 version. We're using this one and not release 2. And on the ADM side, we have, I think in the end, like every other tool builder, we're picking those elements that look to be useful. And it helps us, just keeps us from inventing those things ourselves.
So this conference is called product lines in model-driven development, synergies. So what are these synergies? Is model-driven development basically the same thing as product lines? Does it make sense to use model-driven development for one-up applications if you don't do product lines? Or the other way around, is it today useful to do product line engineering without doing model-driven development and formal modeling? Where do we think are the synergies there?
Probably to most of your questions, the answer is yes. It is my opinion that and it has been proven, you can do obviously software product lines without.
Yeah, that's why I said today. Model-driven
development, and you will probably do it in certain domains still in 10 years. We can probably agree on this, or maybe we can agree on this, that there will be parts of the whole computer scientific domain where models are not that useful, and there will probably an overlap between software product line domain and those domain.
The reason why I'm asking is because whenever we talk about product lines, you're one of the first people to mention that it's important to formally, and I was pointing at Danilo, by the way, when I said you can't see that on the podcast. So, so you're one of the first to point out that it's important to formally describe the variabilities between the different products in the product line, and these descriptions are models. So you could easily argue that this is a form of model-driven development where the models aren't structural like UML or some other graphs basically, but rather the model is a configuration of a feature model. So in that sense, maybe.
Yeah, well, actually what we try to teach our customers is to do as much formalization as possible in the given context. And one of the important things in the software product line area is to model the variability, and we try to make them use formalisms for this. Yeah. But there are other parts, usually the implementation part is in many cases not formalizable in a model, since we have legacy components and it doesn't really make sense for very small applications to build a generator often. And software product lines are, on the other hand, often a lot of many similar small applications.
Well, the synergy between MDSD and product line engineering, I think there's an overlap in process, or could be a useful overlap in process.
This domain engineering and application engineering, for example, stuff.
Exactly. And okay, one can live without the other. I think we all agree about that. I think what Markus said is right, that MDSD is an abstract concept which covers the concept of feature modeling and variance in some way.
There might be one subtle difference, though. When I look at what SAP does with its 30,000 roughly configuration switches we have in our business suite, imagine how many combinations that results in. It's vast. And when I look at the processes and the ways how that is developed, we heard it in one of the talks today that those are mainly configuration tables. So eventually what happens is you have a very lean UI that just helps you add configuration time, which is not design time, and thus fundamentally different from the processes we use in model-driven development. So a configurator or a consultant working during the implementation phase at a customer will set those configuration switches which map directly into a configuration table. No code will be changed. There will be no generation step. There will be nothing except that an if will take another route in the code. So that, I think, is a difference, maybe not so subtle when I think about it, maybe even more fundamental, between the model-driven development processes and tooling that we observe and the ways that configurations of product lines sometimes work.
One clear way where models make sense in a product lines is that if you want to raise the abstraction higher, because today the variability is very difficult to maintain the code, and models are an obvious way to do that. And it's a very known principle already from 80s to build domain-specific languages. Then there were more textual ones, which then describe only what is different among family members. and then tied with the code generators, then you could also produce new kind of functionality, not just configurations, but you can also build totally new kind of applications that didn't exist anymore or before that.
So one of the reasons I was asking is because if you talk to PLE people, product line people, then they typically talk about configuration models. It's basically this feature modeling stuff. And if you talk to model-driven development folks, they talk about things like UML or other graphical or textual languages. So the PLE stuff is more the configuration kind of thing, whereas the model-driven people more have this creative construction approach, to use the two terms that Krzysztof Czarnecki at some point introduced, where you creatively build something from a set of primitives defined in a meta model. So I kind of don't see necessarily how, I mean, the two communities just have a different focus, but you can still do model-driven development with feature models or product line engineering with structural models. So that's why I was asking. It seems these things are a little bit, they have different backgrounds or different...
Well, I think that in my opinion, model-driven development is one of the very good ways to implement software product lines much more efficient than we do today. And on the other hand, the configuration models, which we have talked about, are an integral part of the software product line development, not only on the technical issue, on a technical side, but also for the management of the whole life cycle of application development. And software product line development is much more than configuration. It's about how you get the information, how you use the information throughout the development process. And that's the difference. Model-driven development is somehow a relatively technical thing. And most of the problems in software product line development are basically on the management issues. There are management issues. And so there is a big overlap in the technical things, and then we have other things in software product line, which are actually more of a problem than the technical configuration.
One clear distinction that I see among people who do configuration and those who use domain-specific languages to make variants is that are the applications already available during the production. In people who do configurations, they expect that all the variants are already available, implementation code is available, and then the code is combined with the configurations. That is fine and works in some areas. Then there are other areas where you can't expect that the code is already available, and you can build a domain-specific language on top of the platform, and then you can also make new functionality, not just the configuration, but you can actually make new code from the models.
My feeling is just talking about model-driven is too indifferent. You know, model-driven, you have to understand first in which direction the abstraction goes in your model. So there are model-driven approaches based on UML, which is a completely different approach than a model-driven development based on feature models. So they're orthogonal, this concept. Or something like domain-specific languages, and that's one of the problems we had right in the beginning. What does the word mean? And probably we need new words, or we have to be clear about that.
Yeah, let's invent new terminology.
That sounds good. Yeah. Yeah, we have to be serious about that. I had a presentation some month ago in Italy, and we're talking about a model-driven approach. And after talking 1 hour and explaining what can be done and what we're doing, there was a question: well, and where are the UML diagrams?
Yeah.
That's probably because of my English or their understanding of English. I don't know.
You can have the same thing if you go into the automotive domain, where model-based development, they call it, is identical to saying we use a specific product called MATLAB Simulink, and
right.
that took me a while to understand.
So do we have any opinions as a group on what's more useful, textual or graphical DSLs, or are there any sweet spots for either of them? I think Pekka, I think you have an opinion there.
They don't need to only be, in my mind, just textual or graphical. They can be also table-based or matrices. And the representational form and the notation, so to speak, should be selected on what feels most natural in that application area. If the developers feel that text is fine, then they should build a domain-specific language based on text. If they see that they need to see connections between elements and they want to use matrices, then the domain-specific language should be based on matrix, or graphical one, like many of them are. It's a choice of the person who defines the language.
Right. I would also agree that a lot of personal preferences of the modelers or developers or whatever you call them is involved. I think in addition to that, we can see that text-based is still a lot better understood than graphical modeling. When you think about those tougher problems like how to merge those models or what happens in case of changes in the abstract pieces of the model, how do you have to adapt the graphical representation in those guys? He's longing for the mic. So I think we understand that better today for text-based stuff. That doesn't necessarily mean that we're never going to get it for the graphical stuff.
In text-based development, we have horrible problems with versioning, having the same files and copy the same text in multiple places, and it's very horrible, but people get used to that. That's the way of living. If I change my header file, I need to remember that to change also my C file. So people get used to that, they are inconsistent, and then there's no problem with the text solver.
I've never seen that in Java, but I think copy and paste, of course, could also happen with graphical models.
I think there is again this basic misunderstanding for model. A model is not just some boxes drawn and lines between it. That's not a model. Although everybody thinks models have to be boxes and lines and things like that. Models can be text as well. The model is what is in a metadata, and boxes and lines and text are representations of that, are renderings.
Obviously, yeah.
There are renderings, and so the discussion is a little bit misleading whether it should be boxes or text.
I agree, but concrete syntax matters as well for ergonomical, from an ergonomical point of view, because it's not the same for people if they write text or if they have a graphical representation.
And a good argument to that point that concrete syntax does matter is the lack of success of the UML action semantics, which might have been caused by the lack of a concrete syntax for it.
So maybe let's briefly visit another topic, which is today's tools for modeling. Some of them, there are several issues. One is, of course, the usability of some of the tools to build editors. Some of them are not that great. Others are maybe better. I'm again looking at somebody. And then there is maybe the scalability of some of the underlying infrastructure, which is an interesting topic. For example, if you look at EMF and you have all those XML or XMI files which reference each other by various more or less scalable and robust means, then the question is how can you actually build an enterprise-wide modeling infrastructure? So I think this is an interesting topic. So who wants to say something first?
We at SAP are trying to do that. It might well be that we are proven wrong, and then I have to say we didn't know how to do it. But the way we think how it can be done is starting out with the repository aspects first, so not handle all the problems at once. I think a reasonable, scalable, multi-user capable repository is key to success in that area. I presented today a couple of the features that it has to have. Then on top of that, you have to have all the various services, including tool building support and reasonable frameworks. And I think standards do not matter so much. It has to be easy, and I completely agree with other tool builders on the table on that issue.
Today we have a presentation from Beuche on building domain-specific languages and generating HMI. And even though they generate the HMI and can execute it, the people still would like to use a PowerPoint because that's what they have used to. So clearly, if you want to use structure or formalism, we are forcing people to use some other tools than the PowerPoint. But I guess the task for tool developers is then trying to make the modeling functionality looking as easy as a PowerPoint could be.
Yeah.
But that's a horrible idea.
There was this other joke going around when people talked about executable UML, which is stripped down to have very precise semantics, that the next evolution would be executive UML, which is basically a PowerPoint profile which has absolutely no semantics.
Actually, I'm curious to see what will come along when we have the, what's it called, smart documents with Office 12.
What's that?
what it gives you, as far as I understood it, a colleague of mine presented the ideas to me. As far as I understood it, you can have specific XML bridges to underlying XML documents, and you can link those things to the elements in your Office documents. So, for example, you can set up a PowerPoint frame and then have specific elements in the presentation that relate to data coming from the outside. And I was thinking that could be a way of using that as a tool front end, obviously.
Yeah. Okay, I have two more questions, and I think then we have to go because there is some social event or party this evening which we probably shouldn't miss. So one is MDD and offshoring. I've always argued, also in some of the previous podcast episodes, that if you do MDD right, then there is no economic benefit in offshoring because you can get the same improvement or the same reducement in amount of money you have to spend. Basically, it's going to get cheaper. So, any opinion there? Any experience there, maybe, where we can say that offshoring can be, we don't have to offshore and rather do model-driven development? Any opinion? I can also cut out the question if nobody's answering.
I've seen that some people use model-driven development as an argument for offshoring. They say we can ship the models then to somewhere else, and then people there can use tools to...
They press the button.
Then they press the button, basically. Well, that means that they have to do less work and it can be better controlled. I don't buy into that vision in the first place. I think it is off by far. I think there is a lot of other issues in offshoring. We at SAP are, I would call it experimenting with it. That we have labs all over the world, Israel, in Bangalore, India. We have labs in China. I wouldn't think that whether or not you model changes anything in the fundamental aspects of the game. Executives still perceive the cost difference. As I said, they perceive it. It's a seeming cost difference that doesn't really exist, if you ask me. There is all kinds of risks involved in offshoring and difficulties, and modeling doesn't influence that significantly, I think.
I don't know whether there's a real experience with offshoring or nearshoring and model-driven software development, but what we observe is that there is a kind of movement into that direction, a movement for offshoring and a movement for using model-driven things to build a kind of frame for safety net for offshoring. We have no experience if this is practical or not, but I think we all have to deal with the market and with the market aspects, and offshoring is a theme that is present on the market. And maybe model-driven development can be integrated in an offshore scenario.
So what would be the way? I mean, our analysts draw the models and the offshore folks implement the generator, or do we implement the generator because we want to standardize our architecture and then they draw the model based on Word documents, or are they literally just going to press the button, which is obviously stupid because it doesn't matter where I press the button. So, I mean, what would be the way?
I think...
People are fighting over the microphone, so...
I won one.
Okay, yeah, we have two, so...
Okay. Well, one major argument for offshoring is the cost of the people. In other parts of the industry, there is a good answer to that. If we don't try to move the factories to another country, we start to automate our processes. So I think that's a new idea for software developers probably, but something we should consider is to add more automation into development, and MDD can be part of this idea, part of the solution for that. I cannot imagine it's a complete nonsense to use model-driven development to do it offshore. So what is the use of that?
Just to quickly reply to that, I think it depends on the way you do your model-driven setup. If you can completely generate the applications out of the models, I would completely agree. There is no sense in somehow trying to combine that with offshoring. It's exactly like automating production-intensive processes in other parts of the industry or other industries. However, what I've seen in several cases is that there is need to refine the products of the generation steps or the model transformation steps. Yep. And in those cases, the question remains, who does those things? And I think there is reason in trying to offshore those parts of the process, having the specifications of the models in the high-cost locations, and then trying to offshore the refinement to lower-cost locations.
Okay, last question before we wrap up today. So we're here in this model-driven and product lines conference. You know, there are about 100 participants or something. So some people say that's because we're in some remote part of Germany because that so few people are here, but that's of course cynical. The question is, how widely spread, how well adopted is all this model-driven and product line stuff really? I mean, is it mainstream already? How fast is it becoming mainstream?
We carried last month a market survey in German-speaking Europe, and 70% of the interviewed people who made a product line, who made products, new model-based development approaches like domain-specific modeling or Visual Studio Team System modeling tools, DSL tools, or Eclipse modeling framework. So 70% people know. Not so many are using it. So right. There is something to do. But the knowledge is there, and increasing number of companies are starting to move them and considering to use them. So clearly there are steps to be taken still.
So are we happy? Is it being adopted fast enough? I mean, after the initial MDA hype, things have, my feeling is that things have slowed down considerably, that it's not, the adoption of model-driven stuff is not as fast as people could have thought.
Isn't it clear? UML is now 10 years old and it hasn't delivered the promises it gave. So of course people are skeptical.
What about the more product line oriented things, Danilo?
I have a PowerPoint slide which I adjust every year, which has 2 arrows. One is the timeline, and one is the use of product lines. And I adjusted one by centimeter each year. So
you extend the timeline, but you don't change anything about.
I just put it a little bit closer to where I say everybody knows at least about it, and there is an emerging use of these technologies in where it should be used in the first place. 5 years ago, nobody really knew what it was talking about, and now we are able to talk about these problems, and we finally get some companies to see that there are already solutions to some of the problems they have. So I guess there has been some progress, and I feel that the last 5 years were quite important in this area. But
although it's funny because, for example, the OMG still didn't include feature modeling into the UML, which would be terribly useful. And they didn't do it. So at least the main. Okay, we're again at this OMG thing, but no, I was just saying that they didn't include it. Okay, there was no opinion there.
Well, the thing is that this kind of modeling is something which also other standardization bodies failed to do. If you look at AUTOSAR, a standardization among automotive software development companies, they had a working group for exactly this thing, and after 2 years they simply gave up and said we can't do it.
I think the model-driven business has caught on quite a bit. A lot of people in the environment that I see are using it in one way or another. SAP, as I showed today, is using it big time. The true problem is the heterogeneity due to the absence of working standards, probably. So you see that proliferation of tools and repositories and
Juha, Pekka nodding.
And technologies and frameworks and workbench environments and whatnot. And the problem is the things don't really yet fit together in a way that it becomes industrially viable in a big scope, let's say. And I think we have to get that changed.
You know, one final comment or observation there. Recently, a world famous, as they put it, modeling tool vendor released a new modeling tool. And what they can do basically is they can do class diagrams, UML class diagrams, and their primary sales argument is they can do round-trip engineering. So, you know, again, this class picture to class code, which is, as we all agree, probably useless, more or less, or completely. So either the company didn't get it, or, which I think is more likely, they advertise with this round-trip engineering because people want to have it. So people didn't get it. So weren't we able to? Yeah, the second one. So weren't we able to transport the message? Are people still on this round-trip class diagram to class file level?
The together problem that you mentioned that addressed two pain points at once, and they did it in an appropriate way, killing those two pains. The one pain was that executives kept asking for diagrams, trying to explain what the architecture or the design looks like, and developers hated to use UML tools. So they together killed both pain points at once. Developers could continue writing code, and then on a press of a button produce the diagrams, and the executives would just shut up.
This is kind of an model alibi or alibi modeling. It's just like in the past when C++ was introduced, all of a sudden every C programmer was an object-oriented programmer.
Because it had the plus in the name, and you could have done classes if you knew what they were.
Yes. Yeah, this is just the same. You should take just a piece of Java code, drop it into this machine, and you get nice pictures. So you have a model. So you're doing modeling. And looking a little bit back, we had this flowchart diagram machines, taking some COBOL code or something like that, drawing flowchart, exactly the same. That is, for all those people that don't like to use models, they will use these tools.
So it's about reverse engineering what's already there.
No, it's not a reverse engineering.
Okay, it's a visualization of code structures.
Yeah, but it's just only to have something to pin it at a. Yeah, to have something to pin it to pin it at a board. That's the idea behind it. You could say, well, we're doing modeling.
Which, by the way, goes to show that in some cases, graphics help. They help understanding structure. But I remember having worked with SNF+J or SNF+.
Yeah.
When was that? Like probably 10, 12 years ago or so. And it was great for visualizing inheritance hierarchies and call graphs and everything. We never called it a modeling tool, but it was just helpful.
I think that's the way the mentioned tool provider sees their development.
I didn't mention any tool provider, by the way. I didn't say together.
Me too.
Okay. So then, thanks everybody, and have fun tonight. Bye. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.